Welcome back. Here we are in Chapter 10, Order of Operations. We put together the four operations, addition, subtraction, multiplication, division, and also exponents, and see how they all combine together. In this lesson, I'll just go through the worksheet and talk about some of the big ideas here. So we are in 10a. In fact, 10a is the only section in this chapter where we just tie things together. And the first thing I want to do is talk about exponents. Now, exponents denote repeated multiplication, and it's a little bit weird. 5 to the 0 equals 1, and that seems like a really strange thing to say. 5 to the 0 equals 1. How can I repeat the multiplication of 5 0 times? But there's a nice demonstration, I think, that shows how exponents that are 0 or exponents that are negative actually work. We start with 5 cubed, and that makes sense. 5 times 5 times 5, and that's 125. Now, I go from there to 5 squared. So I drop my exponent by 1, and the result is 25. Now, I could have also done that by taking the 125 and dividing by 5. So in both cases, I divide by 5. Now, 5 squared, I can divide by 5, and that takes me to 5 to the 1, and 25 divided by 5 is 5. Let's continue. 5 divided by 5, oh, well, 5 divided by 5 is just 1, and when I subtract one exponent, I get 5 to the 0. So it's kind of actually a natural thing that 5 to the 0 should equal 1. And let's keep the pattern going. 5 to the 1, 5 to the 0, 5 to the negative 1, keep dividing by 5, I get 1/5. 5 to the negative 2, 1/25, and so on. So exponents kind of work in this cool way where I can have negative exponents. Now, we put together exponents with the other operations to get the order of operations, and you sometimes see this as PEMDAS, or please excuse my dear Aunt Sally. We basically are thinking parentheses, exponents, multiplication and division, addition and subtraction. And we need to be a little bit careful. The multiplication and division, I group those together because that just occurs left to right as the operation occurs. It's not always multiplication before division. It works left to right. Let me give an example. Let's say I had 12 divided by 3 times 4. So I have division and multiplication together. But even though the m comes first in PEMDAS, I just treat multiplication and division left to right. So the first thing I would do is the 12 divided by 3. So 12 divided by 3 is 4. So that becomes 4 times 4. And now my answer is 16. So that's how I'd compute that. So on your own, try these problems. Fill out those solutions, see if you can make sense of those. And I believe the answers are on the answer sheet, so check your work after that. And that brings us to the 4 fours game. I like this game a lot. This is a fun game that you can play with a group, but it also makes a good puzzle just to work out on your own. Use 4 fours, each exactly once, to make expressions for the numbers 1 to 48. You can use the square root and the number 44. So for example, I can make the number 13 by computing 44 divided by 4 plus the square root of 4. I can make the number 8 by computing 4 raised to the 4 divided by 4 plus 4. So do you see that 4 to the 4 divided by 4, that's 4 raised to the 1, which is just 4, plus 4 gives me 8. Now 16, I can do this in a couple ways. I can just add 4 plus 4 plus 4 plus 4. Or in parentheses, I could take 4 plus 4 minus 4. That just leaves me with 4. And then 4 squared. Now, see how I've done the square root of 4 up there? So you can actually introduce 2's by cleverly using that square root. I think there's another way. Let's say I just want to do 4 times 4. So maybe I can do 4 times 4, which is 16. But now I need like a 1 in there somehow. So I'll do times 4 over 4. Oh, so that's another way I can write 16. So it turns out that often, for any given number, there are many, many different ways to write that number. Let's take another example, 21. Let's suppose I'm trying to make 21. We might think of a way to do this by, if I could compute 25 and then subtract 4. And so I'm just kind of thinking 25 minus 4, how could I do that? Well, 25 is 5 squared, so like a 4 plus 1. So 4 plus 4 over 4 squared gives me 25 minus 4. But no, don't do this. I've made a mistake. Do you see what my mistake is? And my mistake is that I used the digit 2. It's tempting just to square stuff and use the number 2, but you can't. So the way I've written here, the 21 is not a legitimate way to write 21 using the 4 fours game. All right, so when I play this in class, I have teams put answers on the board, but for this homework assignment, this online assignment, do this for me. On the answer sheet on the back where you put your answers, you can see a bunch of blanks there. Here's what I want you to do. Give me 15 new expressions. And I mean like 15 different numbers that you can figure out. So you've put a few of them there. 3 of them are already on there. So make 15 more. And as an extra challenge, one thing that I really want is that you must make an expression for 21. So among your 15, so including 21. All right, there is your challenge. Have fun with this puzzle. It is kind of a fun little puzzle. See what you can do. Come up with creative ways for making your numbers. Play around with the order of operations. And as always, if you have any questions, don't hesitate to contact me. All right.